Hello everyone. In today's video, we are going to talk about the James Webb Space Telescope. The James Webb Space Telescope is a space telescope and an international collaboration among NASA, the European Space Agency, and the Canadian Space Agency. The telescope is named after James E. Webb, who was the administrator of NASA between 1961 to 1968 and played an integral role in the Apollo program. Mr. Webb became the administrator of NASA in 1961, just months before President John F. Kennedy announced the United States' commitment to sending a man to the moon by the year 1970. Webb gave overriding priorities to the success of Apollo program and used his considerable political skills to rally and maintain support for the program, even after three astronauts died in an accident in the year 1967. Webb was also a keen student of public administration and used NASA as a laboratory for his ideas about how to organize large-scale public undertakings in a way that both increased the chances of the program's success and also provided maximum benefit for the country. Webb retired from NASA in 1968, but he remained, however, in service in Washington, serving on various advisory boards and also as a regent of the Smithsonian Institution. NASA has named this large-scale space telescope scheduled for launch in 2018 but was postponed due to some technicalities till December 25, 2021. However, the James Webb Space Telescope has four key goals. The number one goal is to search for light from the first stars and galaxies that form in the universe after the Big Bang. The second goal is to study galaxy formation and evolution. The third goal is to understand star formation and planet formations. And the last goal is to study planetary systems and the origins of life from time immemorial. It is intended to succeed the Hubble Space Telescope as NASA's flagship mission in astrophysics. James Webb Space Telescope was launched last year, as mentioned earlier, on the Ariane flight VA256. It is designed to provide improved infrared resolution and sensitivity over Hubble telescope, viewing objects up to 100 times fainter than the faintest object detectable by Hubble. This will enable a broad range of investigations across the field of astronomy and cosmology, such as the observations of redshift. Some of the oldest and most distant objects and also events in the universe can be detected using the James Webb Space Telescope. And also, a detailed atmospheric characterization of potentially habitable exoplanets will be detected by this powerful and unique telescope. So the James Webb Space Telescope primary mirror, the optical telescope element, consists of 18 hexagonal mirror segments made of gold-plated beryllium, which combine to create a 6.5 meter, which is equivalent to 21 feet diameter mirror. This gives Webb's telescope a light collecting area about 5.6 times as larger as Hubble's 2.4 meter. Unlike the Hubble, which observes in the near ultraviolet, visible, and near infrared, James Webb Space Telescope will observe in a lower frequency range from long wavelength visible light through mid-infrared. This will enable it to observe light redshift objects that are too old, faint, or distant for Hubble. The telescope must be kept below -223 degrees Celsius to -370 degrees Fahrenheit to observe faint signals in the infrared without interference from any other source of warmth. So it will be deployed in space near the Sun, Earth L2 Lagrange point. This is a point in space about 1.5 million kilometers from Earth. The 5 layers of the James Webb Space Telescope, which are kite-shaped sun shield, can protect it from warming by the Sun, Earth, and the Moon at the same time. The James Webb Space Telescope will operate in a hollow orbit, circling around a point in space known as the Sun-Earth L2 Lagrange point, approximately 1.5 million kilometers beyond the Earth's orbit around the Sun. In actual position, it will vary about 200 250 kilometers to 832,000 kilometers from the L2 point at its orbit, keeping it out of both Earth and Moon's shadow. By way of comparison, Hubble orbits 550 kilometers above the Earth's surface, and the Moon is roughly 400,000 kilometers from Earth. Objects near the Sun-Earth L2 point can orbit the Sun in synchrony with the Earth, allowing the telescope to remain at a roughly constant distance with continuous orientation of its unique sun shield and equipment bows toward the Sun, Earth, and the Moon at the same time. Combined with its wide shadow-avoiding orbit, the telescope can simultaneously block incoming heat and light from all three of these objects and avoid even the smallest changes of temperature from Earth and Moon shadows that will affect the communication of its sun-facing side. This arrangement will keep the temperature of the spacecraft constant and below minus 223 degrees Celsius or minus 370 degrees Fahrenheit, necessary for faint infrared observations. So the James Webb Space Telescope is a partnership between different entities. Several thousand scientists, engineers, and technicians spanning 15 countries have contributed to the build, test, and integration of the James Webb Space Telescope. A total of 258 companies, government agencies, and academic institutions are participating in the pre-launch project. 142 from the United States, 104 from 12 European countries, and 12 from Canada. Other countries as NASA partners such as Australia have or will be involved in the post-launch operation. The participating countries are Austria, Belgium, Canada, Czech Republic, Denmark, Finland, France, Germany, Greece, Ireland, Italy, Luxembourg, and finally the Netherlands. So guys, this is the end of today's video about the James Webb Space Telescope. I hope you enjoyed it. Till we meet in my next video. Thank you for viewing.